Okay, let us start. Today we are going to discuss volume integral. Let me fix this first. Our topic is volume integral. Last time we discussed line integral and surface integral. Now, how we define volume integral? It is the expression of this form. We have some scalar field T and we multiply it with d tau. D tau is infinitesimal volume element. We integrate this thing over some volume nu. This thing is our volume integral. This is our volume integral. T is some scalar field. D tau is an infinitesimal volume element, and we integrate this thing over some volume nu. So this is our volume integral. Now d tau can be written as dx dy dz. So it can be written as the product of these three things, dx, dy, and dz. Sometimes we have a vector field inside the integral instead of the scalar field. In that case, we write this way. We write integral b some vector field d tau, which can be further written as integral vx I cap plus vy g cap plus vz e cap times d tau. So v is some vector field, vx, vy, and vz are its rectangular components. We can write it this way. We can write it I cap times integral vx d tau plus g cap integral vy d tau plus e cap integral vz d tau. So this way we express the volume integral when v is vector field. We have pulled out I cap, j cap, and k cap from the integral because they are constants. Now we will discuss a problem on surface integral. Problem is like this. I have a question. You note it down. calculate the surface integral the surface integral of v equal to xz I cap plus x plus 2 times j cap plus y times z square minus 3 k. Calculate the surface integral of v equal to xz I cap plus x plus 2 j cap plus y times z square minus 3 k cap over 5 sides excluding the bottom excluding the bottom of the cubical box. In figure 1, let upward and outward be the positive direction as indicated by the arrows as indicated by the arrows. I repeat the question. We are given a vector field v equal to x z I cap plus x plus 2 j cap plus y times z square minus 3 k cap. We have to calculate the surface integral of this vector field over 5 sides excluding the bottom side of a cubical box, which is indicated in the figure. Figure is like this. I will choose a different color for the figure. Let it be. Figure is like this. This is x. This is y. This is x. This is y. This is z. Then figure is like this. It's like this. I have this way, this way, this way, this way. Now it's done. There's a figure. Then there are coordinates given. Here it is 2. Here it is 2. And here it is 2. right? Now this is a cube with 6 faces. We have to calculate the surface integral over this cube, but excluding the bottom face. We have to consider only 5 faces. Now we name the faces. This front face, I change the color here. This front face, I label as first. So this arrow indicates it is taken as outward. This back face I denote by second. These are two faces. Now this face I denote by third one. This is fourth face. Its arrow is leftwards. This is my fourth face. Fifth one is this one. This is my fifth face. So this is my figure 1. Face 1 is front face. Back face is second. This face is third, labeled as third one. This is fourth face, and upward face is fifth face. I will take the sides one by one. First, we will discuss side 1. So for side 1, x is 2. X is 2. What is my dA vector? dA is, because side 1 is parallel to YZ plane. Therefore, its area element will be written as dy dz, and I write I cap. It indicates this area vector is pointing along positive x direction. X is equal to 2 denotes its location. This face face is located at x is equal to 2. Now what is v dot dA? Because we have to dot the vector field over this area element, which we have taken as dy dz, pointing along positive x direction. We have to dot this with x component of the vector field. X component of the vector field is 2xz. There will be 2xz times dy dz. We would simply take x component of v and dot it with this dA. Its x component is dy dz, and x component of vector field is 2xz. Now since x is 2, it will become 4z dy dz, right? I have substituted 2 for x. 2 times 2 is 4. So it is 4z dy dz. Now I have to take the integral v dot dA, which is simply 4. Then I have dy and z dz. Limits of integration along y, as is indicated in the figure. Along y direction, the face extends from origin to coordinate 2. So it is 0 to 2. And along z direction, the area extends from again the origin to z is equal to, it is 0 to 2. 4 times 0 to 2 dy times 0 to 2 z dz. On solving the integral, it will become 16. It is simple. Integral dy will become y. Then you put the limits. First 2 minus upper limit, then lower, subtract the lower limit, will be 2 minus 0, that is 2. 2 times 4 is 8. And we have here, it will integration of z dz will be z square by 2. Then we put the limits. So when we solve it, this will be 16. So for phase 1, the value of the surface integral is 16. And take the phase second. Take the phase second. For phase second, second phase means back phase. For phase second, x is 0 because of the location of the phase. X is 0. What about dA? dA is again dy dz. I cap, but here we have minus. Why? Because phase second is pointing along negative x direction, because we are taking outward normal. Area vector as outward normal. Again we find v dot dA. v dot dA is minus 2xz dy dz. Minus 2xy, minus is this minus, 2xz is x component of v. So we have multiplied that by dy dz. It is simply 0. Why? Because x is 0. So v dot dA integral is equal to 0 for this second phase. Then we take the third phase. We take the third phase. For third phase, y is 2. Y is 2. Because of the location of the phase, it is located at the coordinate y is equal to 2. What is dA? dA is dx dz j cap, because third phase is parallel to xz plane. That's why it is dx dz. J cap indicates the direction of the area vector. Now what is v dot dA? v dot dA is, you have to take the y component of vector field. Y component of a vector field is x plus 2. So it is simply x plus 2 times dx dz. Then we integrate v dot dA, which is x plus 2 dx times dz. Limits on x are from 0 to 2 and on z 0 to 2. So we have 0 to 2x plus 2 dx times 0 to 2 dz. When we solve the integral, we check it, it will be 12. So for third phase, integral v dot dA turns out to be 12. Now we have fourth phase. Now for fourth phase, y is 0. Fourth phase, y is 0 because it coincides with the origin. So y is 0. What is dA? dA is dx dz g cap, and here we have minus because this area vector is along negative y direction, dx dz because this face is parallel to x z plane. Now what is v dot dA? V dot dA is minus x plus 2 times dx dz. X plus 2 is the y component of the vector field. Then we integrate it. Integral v dot dA is minus x plus 2 integral x plus 2 dx times integral dz. The limits on x are 0 to 2 as indicated on the figure, and on z 0 to 2. 0 to 2 x plus 2 dx, 0 to 2 integral dz. When we solve this integral, it will be minus 12. Then we have the last phase, fifth phase. Fifth phase. For fifth phase, z is 2. Z is 2. What about dA? It is dx dy key cap because the area vector is pointing along positive z direction and it is parallel to x y plane. It is dx dy. And what is v dot dA? It is y times z square minus 3 dx dy. Y times z square minus 3 is the z component of the vector field. So it becomes y times 4 minus 3 dx dy. Where z is 2, z square is 4. It becomes simply y dx dy. We integrate v dot dA to simply dx integral y dy limits of integration are 0 to 2 on x, 0 to 2 on y. When you make the calculation, it turns out to be equal to 4. Therefore, the total flux, therefore the total flux, that is the value of the surface integral over the 4 faces, is we have to sum all the faces. One face was 16 plus second face was 0, then it was 12, then minus 12, then 4. 16 plus 0 plus 12 minus 12 plus 4, which is simply 20. So we have solved this question. We have calculated the surface integral of the given vector field over 5 faces. So this 20 is our answer. This way we solve surface integrals. Now I will give you a question. It's your homework. Simple. Your homework. Question is calculate the Laplacian del square of each of the following scalar fields. First is the root x square minus y square. Second is xy times x square plus y square minus 5z square. Third one is x square plus y square plus z square over its power minus half. Question is calculate the Laplacian of each of the following scalar fields. 3 scalar fields are given. First one is under root x square minus y square. Second is xy times x square plus y square minus 5z square. Third one is x square plus y square plus z square is power minus half. This is your homework. This is all for today. Thank you.